let's do rationalizing the denominator when there is adding and subtracting. Okay, rationalizing the denominator or dividing when there's adding and subtracting. Okay, this one's a little bit different. So whenever you go to reduce, you can't reduce vertically, okay, ever, unless all pieces can be reduced. So it's kind of like when we did our quadratic formula, and you know how we had like 6 plus or minus 2 square root 5 over 8, and then we took just the coefficients that were out front. There was 2 on the top and 1 on the bottom, and we kind of reduced all those. You can do that. So you're going to have more than just one piece on top of another piece. You're going to have like maybe something plus something, or else maybe you'll have addition on the bottom. But if all of your pieces have a coefficient that's divisible by 2, then divide them all by 2. If all of your pieces have a coefficient that's divisible by 3, then divide them all by 3. Okay, same with the radicals. If all of your radicands can be divisible by 3, then you can divide them all by 3. But every piece would have to have a radicand to do that. Okay, so basically what we use is we multiply by the conjugate. Okay, multiply by and it's called conjugate. Okay, and what a conjugate is it's kind of like the opposite pair of difference of squares. You know how difference of squares comes out with one factor that's plus and one factor that's minus? Okay, so what we're doing is whichever one we have, we're going to multiply by the other. So if our denominator has a plus in between, we're going to multiply it by the exact same factor but with a minus in between. And vice versa. If our denominator had a two-piece, like a binomial down there that had a minus, we're going to multiply by the one with plus. Okay, and then I'm going to show you why that works. So multiply by the conjugate. So it's the same binomial, but opposite middle sign. Okay, and again, if you're rationalizing the denominator, you're using the conjugate of the denominator. Okay, so that's how you're picking what you're multiplying by. And don't forget, whenever you do that, you're multiplying the top and bottom by the same thing, right? Or else it doesn't work out. Okay, the whole goal is to get rid of radicals in the denominator. If I have a million in the numerator, it doesn't really matter. I just don't want them in the denominator. Okay? And when you go to reduce all coefficients. So that's numbers coefficient. How am I going to spell it? What am I missing? Is that right? Is there another I in there? Coefficients. Reduce all coefficients if possible. So it's got to, you can't just reduce a couple of them. Okay, you got to do all of them at once. Okay, and we'll go back and I'll show you what that other example is.